Hi there. Alright, to start, we're going to talk about distribution again. So if we think about distribution, and of course you're familiar with that as the mailman property, if we were to look at something like 2 times x plus 6, we distribute this 2, we multiply it by both of those things, it equals 2x plus 12. As you've seen recently, we can make the outside whatever we want to. So if I was to do something like 2x times x plus 6, it doesn't change the way we think about it. We would multiply 2x times x, which is 2x squared. Remembering, of course, there's a 1 right there. And we would do 2x times 6, which is 12x. And that can get as easy or complicated as it needs to be. So if I was to do something like 3x squared times 4x minus 5, if I was to distribute that, it would be 3x squared times 4x, remembering that's to the first. So this would be 12x to the third, and then 3x squared times negative 5 would be negative 15x squared. I could even do it with multiple letters, or I could do something like 5x squared y times the quantity 2y minus 3x. That looks a lot nastier, but it doesn't change the way that we think about or do things. This is just 5x squared times 2y. 5x squared y times 2y. So I multiply the coefficients and get 10. I have x squared, and then I have a y there times a y there would be y squared. Okay, and then I would multiply this by this. So again, multiply the coefficients, get negative 15. Now I have x squared times x, which is x to the third, and I carry along the y because there's nothing going with that. That is the distribution. And of course, we could even distribute to 3 terms. So if I was to do something like 3a times 2a squared plus 4a plus 12, again, in terms of the distribution and what it means, it doesn't change things. It's 3a times 2a squared, which is 6a to the third. 3a times 4a is 12a squared. 3a times 12 is 36a. Okay? Now, given that we have this idea of distribution, we're actually going to start now with something that you're a little bit familiar with. It's called factoring. And what factoring is in the beginning is basically just the reverse of distribution. So we are going to start talking about factoring, a huge component of algebra as you move forward. So, basically, if you think about something that you've done before, if I were to give you 2x plus 6x, of course those are like terms, but we talk about why they're like terms. Okay? Both of these have an x in them. So, if you really think about what this is, I could think about this as coming from a distribution question where I have x being multiplied by 2 plus 6. Of course, 2 plus 6 is 8, and that's why this thing equals 8x. Okay? Back when we learned how to combine like terms, this is the basic idea. We're going to take that one step further now, where we're going to consider what the GCF is altogether. And remember that GCF means greatest common factor. So if I were to look at something like 3x squared plus 12x, I'm going to look for the greatest common factor of those two terms. And that's going to be both a coefficient and potentially a variable. If you notice, this is 3x squared, which means 3 times x times x. And this is 12x, of course. Okay? Both of these numbers have a 3 in them, but then I also see an x in common between these two things, which means that this expression, 3x squared plus 12x, has a GCF of 3x. Okay, so what that means is that I could think of this as a distribution problem where 3x was distributed into two terms. Well, what would those terms be? If I consider 3x times something is 3x squared, that would just be x. 3x times x is 3x squared. And 3x times something is 12x. That would be 4. Okay? 3x squared plus 12x is equal to 3x times x plus 4. This right here is called factored form. This is expanded form. Factored form is taking out the GCF if there is one. Okay? If I was to look at something maybe a little bit more simple than that, if I were to look at 5x plus 25. Okay? Again, consider that this might have looked like a distribution problem in the beginning. And the way we can answer the idea of might be is if a common factor exists. Is there anything in common between these two terms? In this case, it's just the number 5. So what I would do is take my GCF out of there and then write this as a distribution question. 5 times something is 5x. Well, in that case, it would be x. 5 times something is 25. So in this case, it would be 5. And I could just quickly check it. 5 times x is 5x. 5 times 5 is 25. Okay? Keeping in mind, this piece out here is considered the GCF. It wasn't here because there's more than just x in common there. Okay? So, let's see if we can apply that idea a few more times. If I have something like 4c to the third minus 12c squared plus 8c. Well, now I've got 3 terms, but it shouldn't change the way I think about things. Do I have anything in common in all 3 terms? And the answer to that is yes. I see that 4 can be divided into all the coefficients, and I see that c exists in all of these. Keep in mind that that's c to the first, so there's only going to be c to the first in common. So I start by putting 4c on the outside, and now I'm going to write this as a distribution question. So I've been asking 4c times something is 4c cubed. If you think about what that really means, it means that I am dividing this by the GCF. And then I'm going to divide this by the GCF and this by the GCF. Okay, that's how I'm coming up with the things on the inside. So 4c cubed divided by 4c, remember that's to the first, is just simply c squared. And then 12c squared divided by 4c is minus 3c. 8c to the first divided by 4c to the first is just 2. Okay? And again, I could easily check this. 4c times c squared is 4c cubed. 4c times 3c is 12c squared. 4c times 2 is 8c. This is the GCF, which means greatest common factor. This whole thing is the factored form. It's just a different form of writing this original polynomial. Okay? Let's see if you can try a couple. So if I do negative 7y cubed plus 35y squared minus 7y. See if you can factor that by GCF. Pause the video, try it yourself. If you got a GCF of 7y, you are correct. And if I divide all of these by 7y, I would get negative y squared plus 5y minus 1. We will talk about if and when the GCF should be negative later. Okay? Next, try 8a to the fourth b plus 48a to the second b minus 88ab. Pause the video. Try factoring that using GCF. Okay, I got a GCF. I realize that 8 goes into all these. My exponents here, it looks like a to the first would go into all of them, and b to the first would go into all of them. So my GCF is 8ab. Okay? If I divide everything by 8ab, I'm going to get a to the third as my first term. I'm going to get 6a as my second term, and minus 11 as my third term. Again, you could check that by distributing. If I distribute this through, I will in fact get that. Okay? All right, one more. If you have, let's see, 15x to the fourth y squared plus 55x squared y squared minus 150 x cubed y cubed. Okay? Factor that using GCF, but be careful about the exponents. Pause the video and try it. Okay, I have a GCF of 5, and if you look at the variables, I have x to the fourth, x squared, and x to the third. If I think about what all of those mean, every single one of these is going to have at least x times x, which means that my GCF includes x squared. And then if I look at my y's, all of my y's have at least a y squared in them. So my GCF is y squared as well. Okay? And if you had to, again, this means x, 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 y, y. This is x, x, y, y, x, 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 y, y, y. What is the most in common of the variables? Okay? So I'm going to divide out my GCF from each one of these. So 15 divided by 5 is 3. X to the fourth divided by x squared is x squared. Y squared divided by y squared is 1, so I don't need that. Plus 55 divided by 5 is 11. And then x squared, y squared, x squared, y squared. So that stays just like it is. Minus, that's going to be 30x, y. So I should get that polynomial as my factored form. Okay? So the plan is to continue practicing factoring by GCF when you come to class. If you have any questions, please be ready to ask, and we will see you tomorrow.